Okay, hi Miracostans. Right now I want to do a video that I would normally do in a face-to-face class, showing you all the steps to go through to calculate the price elasticity of demand using the midpoint formula. Generally speaking, that's what I would do in a face-to-face class. So to get us started, or if you like, maybe turn to slide 6 on lecture 5. And you will see a demand curve that looks something like this. So we've got our downward sloping demand curve, we've got Q on the x-axis, we've got P for price on the y-axis, and then we've got some points, and what we're going to do is we're going to apply the midpoint formula in order to figure out what the price elasticity of demand is midway between A and B. So this is A, this is B. What do we have for values? On the price axis we've got 30 for A and 10,000 for quantity, and then at point B we've got a value of 25 for the price and 20,000 for the quantity. Okay, so what we're doing when we use the midpoint formula is we're saying to ourselves, what is the price elasticity of demand at a point we'll call M, which is halfway between A and B? So if we think about the coordinates that are halfway between A and B, we're essentially saying 27.5 on the price axis, and then this would be 15,000 on the quantity axis. So now some of you might be asking, well, why do I have to use a midpoint formula? Apart from the fact that that's what I'm looking for on the exam, the midpoint formula is more precise. In other words, if we didn't use the midpoint formula, we would be taking a price elasticity somewhere along this range between A and B. And it's not at all clear that the number that we're going to get is going to be as valid up here as it might be down here. Another reason that I want you to use a midpoint formula is because if you don't use a midpoint formula, the number that you'll get for a price elasticity of demand will depend on whether or not you start at A and go over here to B. If you do that, you'll get one number. If you start over here at B instead and go over here to A, you'll get a completely different number. If you use the midpoint formula, it doesn't matter whether or not you start at A and go to B or start at B and go to A, you'll get the exact same number. All right, so let's go ahead and think about what our elasticity formula looks like. So E sub D is equal to the percentage change. Triangle is delta. Delta means change, the percentage change in quantity demanded, divided by the percentage change in the price. Now, because we're using the midpoint formula, we have to set up a complex fraction. And some of you may not have worked with complex fractions in a while. You may be a little bit rusty. This is the purpose of this video, is to help you go through all the steps. So what we're going to do when we set up a complex fraction is we're setting up a fraction on top of a fraction. So what we have over here are changes in quantity. So we're going to take our Q's over here and we're going to put them in up here, and we're taking our P's from the y-axis and we're putting it down here. So what do our change in quantities look like? We're going to have over here 10,000 minus 20,000 divided by 10,000 plus 20,000, but this is going to be divided by 2, okay? And then over here, so we've got our quantities here. Now we're going to take our prices. At a quantity of 10,000, we've got a price of 30. So we've got 30 minus 25 divided by 30 plus 25 divided by 2. All right, so the next thing I would do is I would go ahead and simplify as much as possible. And by the way, I know a lot of you might have calculators that will give you the formula. If you key in all the correct values for your complex fraction, it should spit out the right number. Personally, I would recommend going through as many of these steps as you possibly can, and then key in the final numbers to get your price elasticity of demand. The reason I suggest that is because those calculators, I'm sure, do a fine job if you've keyed in all the numbers correctly, but you've got a lot of different numbers here, and it could very well turn out that you don't key them in the order your calculator expects it, and then you wind up getting the answer wrong. We don't want that to happen, right? All right, so what do we have over here? We've got 10,000 minus 20,000. So we've got negative 10,000. And then in the denominator portion of our numerator, we've got 15,000, right? 10,000 plus 20,000 divided by 2 is 15,000. And then what are we going to do? We're going to divide that by whatever we have here in the denominator. So 30 minus 25 is equal to 5, and then halfway between 25 and 30 is 27.5. So we've got 27.5 over there. So now what could we do? We could simplify a little bit maybe. So why don't we, well, yeah, why don't we go ahead and simplify? We can do this. We can, actually let's not. Let's go to the next step. When we have a complex fraction and we've gotten this far, one of the things we need to do now is think about how we solve this. Again, you could put this all in your calculator, but I don't think that that's a good idea. The next step to solving a complex fraction is to multiply by the reciprocal. So what I'm going to do over here is I'm going to rewrite this as 10,000 over 15,000, and we're going to multiply this by 27.5 over 5. Okay, so now what can we do? Well, now what we could do is we could try to simplify at this point. So we want to make sure we get this all set up correctly. So what I would do is I would cancel here. So this is 1, and then this would be negative 2,000, right? If we divide 5 into 10,000, we get negative 10,000, we get negative 2,000. So now what do we have? We have negative 2,000 times 27.5. That's going to be equal to negative 55,000. Don't forget, we're going to be taking the absolute value of this number too, so keep that in mind. Divided by 15,000 times 1, and this is absolute value of this. So what does that wind up working out to? Our price elasticity of demand is going to be equal to the absolute value of negative 3.7, if I did my math right, which means that a 1% increase in the price will lead to a 3.7% decrease in quantity demanded. This is very elastic. If this were your product, you probably would not want to raise the price. In fact, if your goal was to increase total revenue, you might want to lower the price. But anyway, this is how we go about calculating a price elasticity of demand using the midpoint formula in case it's been a while since you've solved for a complex fraction. Thanks a lot, folks.